everyone, greeting from Phuket. Thank you for joining me today, Beyond via Space podcast. And I'm very excited to have today's guest, Dr. Zubrin. He is well known for his advocacy of Mars settlement. He is a founder and president of Pioneer Astronautics. He has a BA in Applied Mathematics from the University of Rochester and a master degree in astronautics and a PhD in nuclear engineering, both from University of Washington. He has nearly 30 years industry experience, more than 200 technical and non-technical publications covering the area of astronautics, aerospace, fossil fuel, and nuclear engineering. He has 14 US patents and 7 published books. Sure, you have heard The Case for Mars. Let's very welcome Dr. Zubrin. Welcome, Dr. Zubrin, and so great to have you.
My pleasure.
Great. So, because you are so well known as an advocate for Mars settlement, and so I think today our discussion will split to a few parts. So the first part, we're going to talk about Mars, and then we're going to talk about space mining, and then space economy, if that's okay with you.
Sure.
Perfect. And so my first question, and I think although it was very, very clearly articulated in your book, but just for the benefit of our listeners, if you could explain what makes Mars an attractive destination for human settlement?
Well,
and how does it compare to other potential destinations like Moon or Venus?
Okay.
Sorry.
Well, it's the closest world that has on it all the materials needed for human settlement and that has an acceptable temperature range. Venus is much too hot. You can't deal with that. It's hot enough to melt lead on Venus. So Venus is out. Okay. Now, the Moon, close to the Earth, that's its chief advantage, but it has very little water. The only water on the Moon is in permanently shadowed craters near the South Pole. Otherwise, it's basically totally dry. Whereas on Mars, you have continent-sized regions on Mars that are 60% water by weight. You've got glaciers of pure water ice as far south as 38 degrees north, which is the same latitude as San Francisco on Earth. You've got carbon, which of course we are carbon-based life forms, and everything we eat and everything we wear is made of carbon. There's nitrogen on Mars. There's no nitrogen on the Moon. Mars has got a 24-hour day. The Moon is 2 weeks of light, 2 weeks of dark. It's not really what you want. Mars has had a complex geological history, which is necessary to concentrate elements to create useful mineral ore. The Moon has not. It's just Mars is a vastly superior place. The Moon's closer, yes, but Greenland was closer to Europe than North America, and Europeans did discover Greenland before they discovered North America, but they couldn't really settle there. Okay. And so to the coming age of space, Mars compares to the Moon as North America compares to Greenland. It's just, it's a new world. It's not just a rock.
So basically, when we talk about there's material like water, carbon, nitrogen, and also how the day and the night settles, just seems Mars a lot more preferential than the Moon.
Yes.
But the distance is a bit of consideration, right?
Well, it takes 6 months to travel from Earth to Mars. Okay. Well, 1800s, it took 6 months to sail from England to Australia. And they settled Australia. And so we can settle Mars. Yes. It's not a good destination for tourism. Tourists want to come and they want to go. But if you're settling, a 6-month voyage is not out of the question because you're going to spend the rest of your life in the new world.
That is very much appealing and convincing, but I'm sure there is quite a bit of challenging we need to overcome. Actually, I just wondering that for us to achieve the manned mission to Mars, let's say able to spend, a month there before getting back, what is the technology we will need to be able to reach to achieve that?
Okay, well, first of all, if you want to do an intelligent mission to Mars, it's going to take 6 months to go, 6 months to come back. You're going to be there about a year and a half. Okay. And if you think about it, if you're spending a year traveling, you don't want to spend 1 month at the destination. That's like taking a vacation in Hawaii and spending 10 days in the airplane and 1 day at the beach. Okay. That is not what you'd want to do.
That's true.
Okay. So now you're saying, okay, what technologies do we need? In terms of transportation, the chemical rockets are good enough. They can get us there in 6 months. And we've had quite a few of our Mars probes that we've actually launched have traveled from Earth to Mars in about 6 months. So that'll do it. Okay, we need reliable long-duration life support systems. We're going to need systems that will allow us to take Martian materials and turn them into useful resources. First and foremost, we want to take carbon dioxide and water on Mars, make it into propellants, make it into food, which of course is what plants actually do. We're going to want automated greenhouses. We're going to want to make technologies for taking Martian soil and extracting the iron out of it to make steel. We're going to want to take the carbon and hydrogen in the Martian environment to make plastics and artificial fabrics, things like that, all this sort of thing. I mean, look, the question of whether you could live somewhere depends upon whether you can use the resources that are there. You know, the Polynesian islanders can live quite well because, you know, they know how to fish. But imagine if you lived on an island and didn't know how to fish. Then the ocean would not be a resource for you. Okay? If you're a capable fisherman, then the ocean is a bountiful resource for you. Okay? So the question of whether an environment is resource rich or resource poor depends upon what you know. You know, you take these Arab countries. Until we developed oil as a resource and the technology for drilling it, these were just, you know, deserts, right? Now, some of those places are among the resource rich in the world. And that's how it is. I think there's plenty of potential resources on Mars, but we have to turn them into actual resources, and technology is what does that.
And that resource, do you mean actually mineral resource for lots?
Well, no, it's everything, okay? That is all. They just announced a discovery of how to make superconducting wire, room temperature superconductors. You may have read the news story. And guess what? All the elements in that superconductor are common elements. There's nothing special. It's hydrogen, carbon, sulfur. There's no weird rare earths or anything like that. It's just put together in a different way. Okay? And all of a sudden you've got this superconducting wire. You know, human beings did not originate in the countries where they now are. Human beings do not come from Singapore. They did not come from Colorado. They didn't come from China. They came from Kenya. Okay? That is where our ancestors originally came from. In a real sense, humans are not native to the earth. They're native to Kenya. We're actually tropical animals, which is why we have these long, thin arms with no fur. Okay? We're not really meant to live in most of the places that, or we're not biologically evolved to live in most of the places where we currently live. We live there because we invented the technologies that allowed us to become a global species. Okay? And places that would have seemed completely barren to early tropical people coming out of Africa are now actually among the much more desirable places to live than Africa. Natural habitat by far. And so you go to Mars, okay, yes, you're going to want to make fuel, oxygen, food, plastics, steel, glass, aluminum, all these things. You're going to want to extract trace uranium from Martian rocks and make nuclear power. You're going to want, deuterium, which is heavy hydrogen, is 5 times as common on Mars as it is on Earth. If you can build a fusion reactor, there's infinite energy. These are the resources. And then the resources are also in the culture. You need to create a culture of invention, because if you have a culture of invention, then you're like the Polynesians who know how to fish. The water is filled with food. If you don't have a culture of invention, it's just salt water. What good is it?
Agree.
Okay.
So would you say actually the biggest challenging, what you describe is about that actually how we can utilize the localized, the mass resource for our better living there. I mean, it's almost about how we can better adopt it, right? And throughout that, we actually need to have more technology and more inventions enable us to better utilize the local resource. So actually, do you think that the initial mass settlement mission, the biggest challenging to overcome will more come from a political or technology or financial or medical? I mean, what do you think where will be the biggest challenging from which angle for enable the human settlement?
Well,
in mass.
Now that I think about it in these terms, in a certain sense, it's social. It is how to create a culture of invention. I mean, think about it this way, because you're a businesswoman, okay? And you can have a group of people and they could be very poor and seem to be in a hopeless economic position. But if the right person comes along and organizes them into a company, the company can become very successful and all those people can be very highly paid employees of a highly successful company, okay? And in other words, you can literally create wealth out of nothing if you have the right social organization and morale and plan. That's what there is to it. You could take a bunch of people who are currently unemployed and don't know what to do and put them together in a company and you say, look, just work with me here, people, for a week and we're going to get this thing going and you'll all have houses, you'll all have cars, you'll all have everything because we're going to make money. It can be done, right? And, well, it's the same thing with Mars. If you take a group of people and say you're going to a place where the rules haven't been written yet. Now, of course, you want talented people, but you recruit talented people. And there's talented people there because there are a lot of people who will, and people want to do something important with their lives, or a lot of people do. And a lot of those people are highly skilled. They know a lot about technology and science or other things. And you say, look, we're going to make humanity multi-planet species. And, you know, in a sense, this is what Elon Musk has done with SpaceX. He's created an incredible organization, very talented people with extremely high morale and dedication. And they're, you know, blowing away everyone's expectations. Well, you could do this on Mars. And especially since, once again, you're going to a place where the rules haven't been written yet. And this is a tremendous advantage. You've got a clean slate and you've got, it's all there. There's nothing to stop you from doing what you want to do, provided you can think of the right things to do.
Wow. Considering that how much we have advanced as a human race, would you say that the invention kind of desire is actually built in our DNA? And look at how our modern life operates. Look at like ChatGPT, right? Almost like replace a lot of capacities, like what a lawyer does, even what a doctor does, what a coder does. Do you think we actually already ready? We just need to find these group people and have the mission to make the human race as a multi-planetary species, and then we just boom, go there. Do you think that we actually, you know, if the issue is about finding the talent people?
I mean, look, there's some engineering that needs to be done, but look, we're right now, Starship will make its first attempt at reaching orbit within weeks from now. Okay. And it may fail, but you know, they've built several. They're ready for failure. That, you know, Musk failed 3 times before the Falcon 1 first worked. He failed 5 times in landing the Falcon 9. He failed 5 times in landing the Starship. This guy is ready to take some hits before he pushes through to success. And that's what you need. And they're going to do it. So now, of course, that's just the ship. There's all the things you need in order to be able to live on Mars. But these things can also be developed too. Now, it's a question, you see, now it's going to take some capital to get going. I think eventually it will make a great deal of money because a Mars colony is going to be an inventor's colony. It's going to produce a great deal of IP. It will. And that's where the profit's going to be. And then there's also going to be profit in supporting asteroid mining.
So it's actually probably even more important to create this kind of commercial ecosystem to enable these scientific research and a lot of engineering to be able to, in a way, benefit and scale.
Right. It's exactly correct. Creating a commercial ecosystem, pulling the right people together, having the right plan, having the vision that will move the capital. The money's there. I mean, there's so much money floating around the earth right now that compared to what's needed to do this.
That I agree. I think
it's there. And there are people who have it who would be willing to put it in this direction if they're convinced that it'll work. Really, that is the key question. The question is, if you will, organizing the business, organizing the society on Mars. You know, I'm actually working on a book right now called New World on Mars, and it's about what can we create on Mars? What's likely to work on Mars? What would it mean for humanity when it does?
Absolutely.
And so that's what this is about. Yes, you know, I'm an engineer. I spend most of my time looking at the specific technologies and figuring out how to make them work. But the bigger issue is how you put together the engineers and all the other people and make, you know, not just how you play the instrument, but how you organize the symphony and how you get people to come to the symphony. What it's about.
Yeah, absolutely.
Yeah.
Like what you said, there are so much more wealth or money on the earth, probably more than what we needed to build Mars settlement.
Vastly more.
And that's why.
Vastly.
Yeah.
Okay. You know, Musk started his SpaceX with a fortune of $180 million. Now, $180 million is a significant piece of money. Most of us would be very happy if we had $180 million. But he's now grown that into a fortune 1,000 times as large as that in the process of building SpaceX and Tesla, another impossible company, if you will, that is electric car companies that always failed before Tesla. There have been dozens of them. There were electric cars before there were gasoline cars. Thomas Edison invented the electric car.
Agree.
Okay, but there it is. It's a question of a vision and commercial organization and plan. And it can be done.
And that's why you have devoted your pretty much entire life to raise awareness, to let people understand that what is, you know, this is not just sci-fi, it's actually possible.
Yes.
And what that will bring to the life, you know, on Earth. Absolutely. I 100% agree with you. And I think a lot of people want to do good with their wealth. Actually, they just don't understand the topic on space. And that's why we have this podcast.
Okay.
So thank you. Thank you again.
Okay.
That leads to my next question. So what will be the most important scientific and engineering goals for Mars settlement in your view?
Okay, first of all, scientific, there's two different areas here. There's certain scientific questions of great interest to humanity at large from what you might call a strictly scientific point of view, although any scientific understanding opens up numerous technological possibilities. Okay. When you understand how a physical, chemical, biological phenomenon works, that creates capabilities. I mean, the essence of technology is taking science, which is an understanding of a phenomena, and then making use of that knowledge. Now, one of the great scientific discoveries we're likely to make on Mars is different kinds of life forms. You see, the early Mars and the early Earth were really a lot alike. They were both warm, wet planets with carbon dioxide-dominated atmospheres and a variety of rocks that were not that different from each other. If life could evolve on Earth, it could evolve on Mars, and probably did. But it didn't necessarily evolve in the exact same way. Okay? You know, just as people in China and people in Europe both needed written methods of recording information. That's a necessity. But they came upon two completely different ways of doing it. Okay? The Chinese alphabet and, say, the Latin alphabet, which is used by English-speaking French people, Germans, Italians, so forth. These are totally different things. And they don't just, the letters don't just look a little different, okay? it works on a completely different set of principles, the two alphabets do. All right? Now, but they accomplish the same goal. You can write books in both of them. Now, on Earth, all life uses the same alphabet. It uses the same information system, RNA and DNA. And this gives it certain capabilities. This is the computational system of Earth life. Okay? But while all life needs a computational system, an information system, it doesn't necessarily have to be this one. And the first computers were machines that worked with cranks and gears. And then they had ones that worked with electrical relays. And then they had vacuum tubes. And then they had ferrite cores. And now they have silicon. And there are people working on quantum computers and DNA computers and all sorts of things. But the different kinds of computers that I just mentioned, they introduced new possibilities of what a computer could possibly do. There are things you can do with a silicon computer you just can't do with a Babbage machine that works on levers and gears, or a vacuum tube computer like we had in World War II, or, so forth. What if the Mars life has a different information system? It almost certainly will. Okay. Well, there's a 50-50 chance that information system is better than the one Earth life has. That is, it's either better or it's worse. So it's 50-50. Now, but furthermore...
How can you know it's better? How can you be so sure?
Well, or put it this way. There's a very good chance that it might be better at some things and worse than others. Okay? All right. So that means that if you take advantage, now it's biotechnology is going to be one of the dominant breakthrough technologies of the 20th century. Okay? All right. The 19th century was about steel and steam, and then electricity and chemistry. The 20th century, was about airplanes and computers and so forth. In the late 20th century, in the late 20th century, we get information technology and so forth.
Yeah.
But the 21st century, in a very significant way, is going to be about biotechnology. And, in science fiction, you read about nano robots, programmable miniature robots that can make whatever you tell them to make, and they can reproduce themselves. So you start with just a pinch of them, and soon you have 1 billion of them, and they can go out and build hotels for you. And then people, well, that's what bacteria are. Bacteria are the real nano robots. Okay, now recently we've learned how to read their code, and even are beginning to learn how to write the code, which means that we could program them. We could program bacteria to make, insulin or growth hormone or synthetic meat or silk or anything. Okay. Well, that's pretty cool, right? But what if there's new kinds of programmable capabilities that would be...
Which we haven't thought about.
We haven't thought about
because
we're only looking at this one information system of life.
Absolutely.
Okay, so if you had this others, then not only would you get the possibility that others, you would get a better sense of what the range of potential possibilities are. See, look, a European or an American who might be acquainted with a variety of Western European languages would have a limited sense of what a language could be. Now, I only know a little bit of Chinese. There are things you do in Chinese that you just don't do in English. You change a word by changing the tone. Okay, that's simply not a feature of European languages. And there are probably things in European languages that you just don't do in Chinese. And so if you knew both Chinese and English, you'd have a much broader sense of what the spectrum of possibilities are of how you might create a language, okay? And you might even be able to think about language features that are not present in either English or Chinese, because you've gotten a sense of what the degree of freedom is that you wouldn't have if you only knew one kind of language, okay? Now, so here, by discovering Martian life, we're going to learn a lot about this. Now, in terms of engineer.
So we're going to have a Martian language as well, maybe.
Well, we may well have Martian languages, but here I was actually talking about
the different form of life, different life forms.
Different life languages, biolanguages, okay? Information systems at the cellular level. But then also just in terms of technologies, there are a number of areas that I can identify where I think the Martians are going to really want to move things ahead very forcefully. One of them is in the area that, in a general sense, could be called labor-saving machinery. And this includes things that are old-fashioned labor-saving machinery, but also things automation, robotics, artificial intelligence, augmented intelligence. These are technologies that multiply the capacity of labor, okay? And the reason why the Martians are going to be virtuosos in this is because there's going to be a tremendous labor shortage on Mars. There's going to be a shortage in both numbers and diversity of skills. And to remedy this, the Martians are going to push technologies that answer this need to the hilt. And now, these sorts of technologies will ultimately be extremely beneficial on Earth, although in the short term, people might not like them because labor-saving technologies have the appearance of causing you to lose jobs. But really what they're doing is they're multiplying the power of labor. And the model for this actually is the United States, because America had a labor shortage. And we answered it by gadgeteering. We developed a culture of gadgeteering, of creating labor-saving devices that were not welcome in Europe, but they were needed here. Now, furthermore, so when you have a labor shortage, pay goes up. That's very attractive to the working man. But the only way you can make that work is if the productivity of the worker is higher. So you get a system based on highly productive labor that is highly paid, as opposed to low productivity labor getting low wages. Okay. And this proved tremendously successful. Now the Martians will have the same dynamic, but multiplied 10 times over.
That's probably why you mentioned before also the nano robotics, right?
Well,
I think that's what probably...
Well, nano robotics, but also I think big robots. I mean, I think we're going to have humanoid robots on Mars, as well as robots of other sizes and shapes, but also humanoid robots, yeah.
Absolutely.
Okay. Now, I think we're also going to have tremendous advantages in biotechnology on Mars, in particular to meet the needs of greenhouse agriculture. As expensive as farmland is on Earth, it's going to be vastly more expensive on Mars because it all has to be in greenhouses instead of in open fields. And that means that you're going to want to really push the limit on productivity per square meter of your farm. You know, if you take a farm on Earth and you say, if we implement this technology, you'll get more per square meter. Okay, now, if it's that simple, the farmer will just say yes. But in general, things are not that simple. In general, there's something else you have to pay for to get that productivity per square meter. Maybe it's more labor. Maybe it's more complex machinery. So far, okay, in order to do that. So when you have a situation where land costs X, okay, productivity per square meter or per hectare or however you want to put it, worth a certain amount, but it has to be balanced against other considerations. On Mars, that balance is going to be tweaked in the direction of maximum productivity. And you're going to want to drive some technologies that people currently don't consider worthwhile on Earth or too high a threshold. Okay, so they're going to invent that. They're going to go for ultra-productive agriculture. They're going to push genetic engineering of crops to the limit, okay, in order to make sure all the different vitamins are in the rice and so forth, and you know, and things that people are doing on Earth to throw up obstacles to this based on, well, you know, we can't have genetically modified food because it could be dangerous, you know. People say, get out of here, okay? We need this. Then I think you're going to have nuclear technologies, including both fission and fusion. The nuclear power plants we have now, which are competitive with fossil fuels when there aren't overregulations. Nevertheless, they only use about 1% of the energy that's in the uranium. 99% of the potential energy is wasted. Now, they can afford to do that because only 5% of the cost of a nuclear power generated electricity is the fuel. So, so there hasn't been a driver to create breeder reactors. And we've known about breeder reactors since the 1950s. We even built one in the 1950s. Now, on Mars, you're not going to want to have to, if you are importing uranium from Earth, you're going to want to get the full value of it, not 1% the value of it. And because it's going to be expensive. Also, if you're mining it, once again, if you've got a very expensive labor, you're going to want to minimize the mining effort to fuel your nuclear reactors. It means you're going to want to get 100%, or at least, 80% of the energy out of the fuel instead of 1%. Okay. So they're going to develop breeder reactors. Okay.
And the reason right now on the Earth that the utilization of the uranium is so low is because it's a very, very small percentage of overall cost.
Yes.
I see.
Right. That's also why you've heard about people pushing thorium reactors. Okay. And thorium is 4 times as common as uranium, and it can be used as a fuel. But once again, people say, what do I need it for? Okay. It's like coming up to you and someone saying, I could save you 20% of the cost of your newspaper subscription. And, you'd say, well, okay, maybe, but I really don't have time to think about that right now. Because it just isn't that important.
It's not a priority.
Right? Okay. Yeah, it'd be nice, but okay.